All right, in chapter 3, we are going to display and talk about categorical variables. To do that, it would be nice to remember a categorical variable is something where your response is a word. What's your gender? What's your favorite subject in school? Do you play a sport? What did you do this past weekend? What are your post high school plans? Are you going to homecoming? Did you go to the football game? So, all of these things are categorical variables. All right, the first thing we want to make sure we know, we're going to be finding out a lot about frequency or frequencies. So, what does frequency mean in this case? So, after we decide what variable we're going to gather data about, we need to count things. So, the frequency is how many people or objects are in each category. So, it's a count of things. So, we're going to be finding a lot of frequencies in class. All right, after we have a frequency, we are going to be able to talk about a distribution. So, what is our class's distribution of sports? So, we would count how many people do play sports and how many people do not play sports. So, a distribution tells you what quote unquote values a variable takes, and maybe they're not quantities, but they're still like the options. So, what options a variable takes. And then again, the frequency, how often each of those variables happens. So last year in zero period, we asked the question, how are you feeling? You're happy to be here, you're or you're done, you want to go home. So last year in zero period, 5 people were like, yes, it's great that we're here. 30 people were like, and 2 people were no, just send me home, I'm already done. Okay, so last year's class, zero period, had 37 people. So that would be a distribution of how do you feel. So we have the values that variable has taken, and we have how often each of those values happens. After you have something like this gathered, we could display that in a bar graph. So let's show you. First of all, though, what's the difference between a bar graph and a histogram? Because they look similar. You've probably seen them in elementary school, and now they're coming back, AP Stats. So the difference between them, they both have bars. Great. Bar graph is for categorical data, and histograms are for quantitative data. So here's kind of a generic made up. So I realize I just showed you data about happy to be here, and want to go home. This is maybe ideal. Lots of people happy to be here. That did not happen in my zero period last year, at least the day we gathered the data. So again, bar graphs are categorical, histograms are quantitative. This comes back in chapters 4 and 5. Chapter 3, we're doing categorical data. So in both cases, the y-axis has frequency. In our bar graph example, our x-axis is the categories of feeling. So we had, yay, send me home. For histograms with quantitative data, we have numbers here at the bottom. You're 16, you're 17, you're 18. This has no gaps in between, unless there's just no 17-year-olds in maybe our data set. Then there'd be a gap, but there's no gaps between the bars like there is over here. So that's the difference between bar graphs and histograms. Categorical data and quantitative data. So let's make that go away. There's a couple of different ways to display categorical data graphically. So some are more common than others, but to display categorical data, you can have a pie chart. You can make a bar graph like we just saw, or a bar chart. There's also something called a segmented bar chart, and that will be explained in the second video. So just FYI, there's 3 ways to display categorical data. Pie chart, it'll add up to 100%. It is a circle typically a pi. Again, bar graphs have frequencies on the side, and segmented bar graphs can also have frequencies on the side. All right, we are going now, 2 more vocabulary words. So this is last period's data. This is last period's data broken down by gender. So we not only found out, who was the happy people to be at school, the and the send me home crowd. Oh, I'm realizing that the frequencies I just told you of 5, 30, and 2 are different than this one. Good times. Okay, well, this was actually period 0 because it says period 0. Okay, so 5 people in 0 period were woohoo. 20 were and 10 were more than the 2 from before. Okay, 10 were send me home. Let's see. So we have this broken down by males and females. Okay, the main question, though, is where can you find a marginal distribution in a two-way table? So this is called a two-way table because we have 2 variables. We have feeling and we have gender. We've got the values each variable takes, sad, and happy. Here's our 2 values for gender, male and female. You can add all these up and figure out that we had 15 males present at the time the survey was taken. We had 20 females present when this survey happened. So that was the breakdown by gender. So marginal distributions do happen in the margins. So let's go ahead and flip this over. So these numbers right here that aren't here, if like I just found the totals, that would be a marginal distribution of gender. And if I found the 3 totals down here, I'd have a marginal distribution for feeling. So let's turn this over and see. Okay, so each two-way table has 2 marginal distributions. They are on the edges, kind of like the margin in a piece of paper. They're the totals of each. So again, it's kind of like a summary. So your summary of gender, 15 males, 20 females. Your summary or your marginal distribution of feeling, our other variable was feeling. We had 5, 20, and 10. Those are the values that each of those have taken. How many people were happy, how many people were and how many people were just done. All right, so that's a marginal distribution. It's found again on the edges, the margins. So each table has 2. Then we can do something fancy and have conditional distributions. So again, we're going to use period 0 from last year's data. If your marginal distribution is on the edge of a table, the only spot left really for any other distributions, conditional distributions, would be inside the table. So any row or column inside the table will be a conditional distribution. So again, they're found inside the table. I put that this table has 5 conditional distributions, so we can kind of count them. Here's a conditional distribution right here, 2 and 3. Here's one right here, 10 and 10. Here's another one, 3 and 7. So in this case, this condition to be in this column, you have to be happy. The condition to be in this column, you had to be This condition to be right here, you had to be not so happy to be here. So those are 3 conditional distributions. Then we have the conditional distributions going this way, the rows. So there's 2 more conditional distributions right there. So here's the conditional distribution for males. There's 2, 10, and 3. So this is the condition to be in this bar, you got to be a guy. So that's the conditional distribution there. And then down here, this row, the condition to be present here in this row somewhere is that you're a female. So they're going to ask questions such as this. Give the distribution of how people feel for females. It might not say in the question, give the conditional distribution. It might just ask it like this. So if you're finding the distribution of how people feel for females, I underline that. That's our condition. They're basically saying, how do the girls feel? So we would go look at the row that contains all of the girls right here, and we would go ahead and give those three values of happy, and not happy. So 3, 10, and 17. We could also make them into percentages if we wanted. That would be using relative frequencies instead of frequency. I'll show you that word in one sec. So here's our 3, our 10, and our 7. So to be recognized for this problem, the condition was that you're a girl, so we're reporting numbers inside the table. Let's go ahead and show you this relative frequency definition just for kicks. So a lot of times answers are given in relative frequencies rather than just frequency. So this whole relative term means that you'll be finding a percentage instead of reporting an actual count. So let's see. So instead of counts on the y-axis, if you were making a bar chart or a bar graph, instead of counts, you'd put percentages. You could also do that when you're giving data for marginal or conditional distributions. So let's do one more using last year's 0 period data here. So let me get rid of this relative frequency. So again, percentages. So let's say for the sad people from last year, too much to show you. Here's our sad people. Okay, so we have this chart from last year's 0 period. It says for the sad people, okay? Well, here's our sad people. This is the condition now. So for our sad people, 3 and 7, give the distribution of gender. So if I just reported like this, 3 guys were sad and 7 girls were sad or didn't want to be here or whatever, that would be the frequency. If I wanted to report it instead as a relative frequency, let me see if I can do that right now. So to do a relative frequency for the condition that you are not so happy to be here, you first need to find the total amount of people not happy to be here. So 3 plus 7, there's 10 people last year's 0 period that weren't so happy to be here. So to find your relative frequency, you would convert, instead of 3, you would divide 3 over 10 and get 30%. Let's go ahead and try to write that. So, and then for our females, what percentage of all the sad people are females? Well, that would be 70%, or 7 out of 10 of our not so happy to be here people were female. So if we report it as 30% and 70% instead of 3 and 7, the percentages would be a relative frequency. The actual numbers 3 and 7 would be frequency. That brings us to the end of part 1 of chapter 3.